In question 4, we have a graph of y is equals to f of x, where f of x is 3 upon 2 cos 2x plus half. Now, this plus half represents that the graph has moved half units upwards, and the 3 upon 2 is the amplitude. So, the maximum point would be half plus 3 upon 2, and the lowest point would be 3 upon 2. So, for the maximum value, we will have half plus 3 upon 2, which is 4 upon 2, which is equals to 2. And the minimum value would be half minus 3 upon 2, which is minus 2 upon 2, which is minus 1. So we can say that the range of f of x is greater than equals to minus 1 and less than equals to positive 2. In the next part, we have a function g that is equals to f of x plus k, where k is a positive constant. The x-axis is the tangent to the curve. Now, if the x-axis is the tangent to the curve, we know that the graph has basically moved upwards and is somewhat like this, which means that this point has moved 1 unit upwards as the lowest point was minus 1. So we can say that k is equals to positive 1. As the movement was only 1 unit in the y direction, we can say that the transformation is a translation. As in translation, we either move in the x or the y axis. And in this case, we only moved in the y axis, so we can say it was a translation of 0 and 1. In part C, we have to state the equation of a curve which is a reflection of y is equals to f of x in the x-axis. Now we know that f of x is equals to 3 upon 2 cos 2x plus half. When it is a reflection in the x-axis, the whole function is multiplied by minus 1, as the part below the x-axis is reflected upwards and the part above the x-axis is reflected downwards in the x-axis. We multiply the whole equation by minus 1, and the equation would be written as minus 3 upon 2 cos 2x minus 1 upon 2.